All right, so up in the top first example, and I know I wrote kind of fast, I'm going to rewind here. Hopefully these are things that maybe we've seen before, but the first one, just adding two matrices together, you're just going to take the first term, add it to the second term. Well, the first term, the first matrix, add it to that second matrix. So the -6 and the 12 are going to get added together. That's going to go for our first entry in that matrix. Same thing, then we're going to add the 3 and the -2. So any corresponding entries get added together. We'll add the -4 and the 5, that'll be the 1, and so on and so forth. Alright, so that should be your first answer for that first matrix. Now remember, you can only add matrices that have the same dimensions. So that'd be number 1. Number 2 is a scalar multiplication problem. So you're just really distributing that 3 into everything in the matrix. So just like if we were distributing it into parentheses, that guy should be your final matrix, and that's a -6 there, not a B. Alright, so number 3 and number 4 are kind of those two processes mixed. So if you want to take a minute, pause the video, try them out, check your answers, you can. If you want to go through and watch me do them, that's fine too. Here it is. Alright, so again, I just used the scalars, multiplied them in these two matrices, and got my answer right here, adding them together. 23 over -8. For number 4, I'm going to choose to add those two matrices together first. So I get the -1 and 1. Then I'm going to multiply it by 2 to get my answer. Now this would be the same as if you distributed the 2 first and then added them together. So all the properties we have up in this kind of warm-up area are really similar to what we have just for normal addition and scalar multiplication distribution.